Hey guys, when I was working with a student yesterday, we discovered that there's a little extension to lesson 5.4 in MyLabs Plus that we haven't discussed together as a class. So I wanted to make a video and share with you an example of how we would go about doing what this little extension is asking us to do. So it's very similar to the examples that we were working through together in class last week with regards to sampling distributions for sample means, where we've learned to use this 5-step process that I have written here on the left side of our screen. But this particular type of question is not about the sampling distribution for sample means, but rather it's about the sampling distribution for sample proportions. And that's when they give you information about like the percent in a population and the percent in a sample, and how likely is it that you get a sample percent that large or larger, or that small or smaller, and so on. So an example might be as follows. It says about 77% of all female heart transplant patients will survive for at least 3 years. So they're basically telling us that in the population of all females, the percent of those that have heart transplants that survive for 3 years or more is 77%. Now 77%, when expressed as a decimal, is equal to, we know, 0.77. You just move the decimal point 2 places to the left. What they're giving us here is the proportion in the population of all females that have the transplant. So we call that P. Okay, that's the population proportion. The example continues on to say that 60 female heart transplant patients were randomly selected. We know that the size of the sample that is selected is little n, and in this case then, n is 60. What is the probability that the sample proportion? Well, you're going to find that we use a p hat, or some textbooks use a p prime to represent a sample proportion. So P is for the population proportion, P prime is, or P hat, is for the sample proportion. So it says, what is the probability that the sample proportion that survived for at least 3 years will be less than 73%? So they're saying P hat is 73% or 0.73. What is the probability that if we take a random sample of 60 patients, that our P hat will be less than 0.73? So that's the question that's being asked here. Now, the process that we use to answer a question like this is very similar to the process that we've used to answer a question about getting a particular sample average. So what I'm going to do is I'm going to add to our 5-step process here the changes that we need to make when we're dealing with proportions instead of means. So what we're going to be interested in is, what is the mean of the sampling distribution for sample proportions? So you're going to see that they use mu sub p hat. And just like with means, it will equal the true population value. Not mean in this case, but proportion. So the true population proportion is P. So in our case here, our sampling distribution should be centered at this true population proportion given in the problem of 0.77. So mu sub p hat will equal 0.77. Step 2, we know, is to find the standard error of our sampling distribution, and with means that was sigma over root n. With proportions, we take the square root of p times q over n. Q is just 1 minus P. So in our case here, we'll find the standard error of our sampling distribution for sample proportions to be equal to the square root of P, we know is 0.77, times 1 minus P, well 1 minus 0.77 is 0.23, divided by the size of our sample, in this case 60. And when you calculate that on your calculator, you should get a standard error of about 0.0543. Step 3 is to draw our normal distribution, and this will be normally distributed because n is large. There's more to why it's large, but this is just an extension, so I won't elaborate on that. So my sampling distribution, I'm running out of space here, should be centered at at the mean that I just determined, which was 0.77, and I should count out by my standard deviations that I just computed in step 2. So I'm going to round to like 0.05. So one standard deviation above the mean would be about 0.82, 2 would be about 0.87, and so on. Down below, one standard deviation below would be 0.77 minus 0.05, 2 standard deviations minus 0.05 again, and so on. So I am interested in this case in finding the probability that our sample proportion will be less than 0.73. Well, 0.73 would be about here. It's above 0.72 but below 0.77. And we're looking for the probability that it will be less than that. So we're looking for the area in that left or lower tail. So step 4, we're going to need to find our z-score. So like we did with means, we're going to take our sample value, in this case our sample proportion, p hat, minus the mean of our sampling distribution, which we've learned here is mu of p hat, and divide by the standard error of our sampling distribution for sample proportions, which we've learned here is sigma sub p hat. So our p hat was 0.73. The mean of all p hats we determined was equal to the population proportion of 0.77. And the standard deviation or standard error of all p hats we calculated was 0.0543. When we plug that into our calculator, we should get a z-score of negative 0.74, if you round it to the nearest hundredth, as we know our table requires. So we are almost 3/4 of a standard deviation below the mean, which looks reasonable given our sketch here. Okay? So now all that we have to do is go to our table and find the proportion or probability that we would be in that tail below a z-score of negative 0.74. And when I look that up in my table, I find when I look up negative 0.7 and then go over to the column that has a 0.04 in the heading of the column, I find that the area below, rounded to 4 significant figures, is 0.2296. So if I take a sample of 60 individuals from this population of women who have had this bypass, and I calculate the proportion who survive for at least 3 years, there's about a 22.96% chance that less than 73% will survive for at least 3 years. If you have questions, don't hesitate to email me.